Introduction to the convolutional neural network. So the convolutional neural networks are a powerful tool in the computer vision, which is mainly used for enabling a computers to understand and interpret the visualized data. So the convolutional neural network, it's a type of a deep learning neural network architecture, which is commonly used in a CV, that is the computer vision. So the computer vision is a field of artificial intelligence that can be enable a computer to understand and interpret the images or visual data. When it comes to the machine learning, the artificial neural networks which can be perform really well. So the neural networks are used in a various data sets like images, audios, and text and all. So the different types of neural networks are used for different purposes. For example, for the prediction, the sequence of words we will take as an example. For that, we can use the recurrent neural network, which is more precisely an LSDM, and similarly for the image classification, also we can using the convolutional neural network. So the next one is the foundation of neural networks. That is neural networks lays in functionality. So the neural networks containing the input layer, hidden layer, and output layer. So first we will discuss about the input layer. So input layers which will give the input to the our model. So the number of neurons in the layer, which is equal to the total number of networks features in our data, or a pixel in the case of images. So this is called as the input layer. Input layer is which is mainly used for receiving the data. The data which can be it's such as the images and pixels. So the next one is the hidden layer. So the input from the input layer, which is we can feed into the hidden layer. There can be many hidden layers depending upon on our model. That is a data size and model. So the layers are depending upon the models. So each hidden layers can have a different numbers of neurons, which are generally greater than the number of features. So the output from the each layers is computed by the matrix multiplication of the output of the previous layers with learnable weights of that layers, and then by addition of the learnable bias followed by the activation function, which makes the neural network is a non-linear. So the next one is the output layer. So the output layer from the hidden layer is then feed into the logistic function. It's like the logistic functions are like a sigmoid or softmax, which is mainly used to converting the output of each classes into the probability score of the each class. So which is these are the functionality of the neural network. The next we are going to discuss about the convolutional neural network architecture. The architecture is mainly containing the convolutional layer, pooling layer, and fully connected layers. So now we are going to discuss about each layers elaborately. So the convolution neural network consists of multiple layers like input layer, convolution layer, and pooling layer, and fully connected layers. So the convolution layer applies the filter to the input function to extract the features at the pooling layers, downsampling the images to reducing the computation, and the function fully connected layer makes the final predictions. So the network learns the optimal filters through the back propagation and gradient descent problem. Next, we will discuss about how convolution layers works. Uh, the convolutional neural networks are convolutions are neural networks that shares their parameters. Imagine that if you have an image, it can be represented as a cuboid. It's having the length, width, and height. Right. So this is an example for that. So how the layers are used to build by using the coordinates. The complete convolution neural network architecture is also known as the coordinates. A coordinates is a sequence of layers, and every layer which is mainly used to transform one volume to the another volume through the differentiable functions. So convolution. Next, we will discuss about the convolution feature extraction. The convolution layers are the filters to have the input images, extracting the features like edges, shapes, and textures. These filters are learned during the training, allowing the network to identify the relevant patterns. So next we will discuss about the activations functions. So first, in the activation layer, by adding the activation function to the output of the preceding layer, activation layers are non-linearity to the network. It will apply an elements-wise activation function to the output of the convolutional layer. Some common activation functions such as the ReLU, max of tan of a leaky relu, etc. These are the activation function we are using in the convolutional neural network. The volume remains unchanged, hence the output will have the dimensions like 32 into 32 into 12. So next we will discuss about the max pooling layer. So mainly we are performing the downsampling for calculating the efficiency of the layer. So the pooling layer is periodically inserted into the coordinates, and its main function is to reduce the size of the volume, which makes the computation fast, reduce the memory, and also preventing from the overfitting. There are two common types of pooling layers are available. One is the max pooling and another one is the average pooling. If we use a max pooling with the 2 cross 2 filters and straight 2 stitches 2, the resultant volume will be of a dimensions like 16 cross 16 cross 12. Next, we will discuss about the flattening, which is mainly used for preparing the classification. So the flattening resulting feature maps are flattened into a one-dimensional vector after the convolution and pooling layers, so they can be passed into completely linked layer for categorization or regression. Next, we will discuss about the applications of convolutional network. So the for mainly the convolutional network is used for transforming the computer vision. The convolutional neural networks are widely used in the various computer vision tasks like image classification, object detection, facial recognition, medical imaging. And their ability to extract in the features and learn complex platforms makes them a powerful tool for solving the real world problems. Thank you.